All right, team, let's begin. Here we go. Chain rule. I want you to copy in your notes. Delta y delta x equals to delta y delta u multiplied to delta u delta x. This is your chain rule that you'll likely be referring to. That makes it easier to understand. The function notation they'll likely put on your exam formula sheet is this one down here. So most students don't know how to read that one. Multiple choice questions next year, they'll likely give you this. This is how you're going to learn it to play. Once you understand it, then reading this will make more sense. Otherwise, this will confuse you. So I'm not going to start here. We're going to start here. Okay, so I want you to copy down this first, and over the term, I will then slowly work you towards understanding this. For those who are much more mathematically inclined, you then can have a go at looking some of the last questions of each exercise. They usually do proofs. They get you to think about it. So, for example, in your textbook, I'm pretty sure there was a question. Here we go. This one. So this is a preliminary introduction to proving. They're obviously giving you y equals x to the power of n, and then they get you to show. So use the chain rule to prove that the derivative is going to be this. Okay, and that's where it's interesting that some students will find that tricky. Later in year 12, they don't get you to do this notation anymore. They will give you something like f of x is equal to g of x, find f dash of x, something like that. And then you need to be able to write that. Okay, so this is, you can only do that once you get used to the formula and understand it. So I'm going to get you to copy just this one first. Delta y delta x, which is the derivative. This is equal to delta y delta u, so derivative of a different function times to another derivative of a different function. This is called a chain rule. I'm going to show you when do you use it and what kind of applications that you can see how we move into it. So on that sheet there, if you have a look at them, every one of them is a chain rule problem. Okay, so this is a very typical basic idea of how to differentiate a non-power function by itself. Okay, so let's give you an example. If you've copied that, or if you haven't, the rules are already on your sheet, so you can copy that rule down. But let's give you an example of why we need to learn this. If I gave you, as an example, y equals x cubed, and I asked you, what is the derivative? So delta y delta x. What is the derivative of x cubed at the moment? You should be able to do this without writing it down. It is? Very good. So we know it is 3x squared. Then I change this problem just a slight difference. This is what I'll do. I'll say, what is y equals now? And I say, I don't know, let's do x plus 2 cubed. Okay? Now, this problem, listening, boys. Thank you. This problem here now challenges us a bit more. What you've done so far in exercise 17b is that you would have to expand this into their individual terms so that you can differentiate each power term by themselves. Was there a shorter way, or is there a shorter way to do this problem? And yes, there is, because if I then gave you to the power of 31, you should still be able to do it without expanding it. This is where chain rule comes in. Okay? Once you understand this concept, the more applications that you can do are something like combining, say, x squared plus 3x cubed minus 1. This you should be able to do in your head. Okay, so there will be a point in this term where I'll ask you, what is the derivative of log base e of, and I can read that out, and you should be able to look at that and tell me what the answer is. Okay, log 1's a bit trickier, but eventually that is the goal. If you can do that, you already chopped down quite a bit of content for next year, chapter 9. That's what they're going to revise again. They're going to practice you to do chain rule. Okay, in fact, they're not revising. Technically, it's a year 12 concept. Okay, but we're introducing it early because it's the bread and butter. So here we go. How do we do this type of problem? So let's change it back to cube. This one we knew how to do. This one we don't know how to do. This one's a bit trickier. right? And the reason why is because of that x plus 2. So what chain rule does is says, well, let's make our life easier. If we didn't have this x plus 2, okay, it would have been sweet. If I had something else, for example, if I had this to be u, the letter u, and that's the term that variable we tend to use. You can use any variable you want. But if it was u, then this would change the problem to now y equals u cubed. So that means if I ask you to find the derivative of this now, this should be no different from what you just did over here. Okay, now the answer should still be 3u squared. Just the same way. There's no difference in terms of the variable, the text. Okay, but the notation is different. This is what we would say delta y, which means change in the y variable. This one was a change in the y variable, but this is now change in x. So we would say delta x here. But what would it be down here then? Delta u. So this is the derivative of this function. So that would have been sweet. It would have been great if we had just the letter u and that was our problem, right? But the reality is that we don't have that letter u. Reality is that's not true, okay? So chain rule attempts to say, well, okay, I can get delta y, delta u. So they're right here. Can I do something with delta y, delta u to get to delta y, delta x? There is. Like, well, actually, if I multiplied this to delta u, delta x, isn't it like fractions where we can say whatever change in u is divided by change in u should be 1? That will give you the answer of delta y, delta x. So the question is, can I find a delta y, a delta u, delta x? Okay, so what it's trying to ask, I'm just going to write it again. They're trying to ask, is it possible to find a function where you have u equals to something in terms of x? That's what they're asking. Well, conveniently, we do. Remember here I said, what if this was u? If u was equal to x plus 2, I now have an equation where it's u and x plus 2. So this means if I found the derivative of this, it should be delta u, delta x. And conveniently, this is a problem that I can still differentiate using power rule. Okay, there will be cases where you can't, and that will be a different scenario there. But at this point, every problem, if you have a look at this later, I'm going to show you, if you have a look at every single term that if you were to replace it and make your life easier, every one of them is differentiable. Even the one I wrote before. Oh, where did I write it? I must have rubbed out. You know the one I wrote, log e of x squared plus 2x minus 1? You see, the problem is not the log e, because once I teach you how to differentiate log e, you can use the rule. The problem is x squared plus 2x minus 1. That's complicated. But if I can remove that, and replace it with another letter, then it's differentiable. But the beauty is that x squared plus 2x minus 1, they're all differentiable. I can do that. I know how to do that. Okay? So, at the moment, every one of these problems here, if we have a look, I'm just going to write a few examples. Let's look at A. So A, notice that you have x plus 2 to the power of negative 4. Looks hard. But if I didn't have that x plus 2, if I replace that with another letter, notice this problem now becomes much easier to do. That's 17C. If you have a look at, say, n. Let's look at n now. Let's have a think about n. So n is y is equal to the square root of 5x squared minus 2. This used to be a 2010 exam question, something like that. Okay, but now it's too easy for you guys, so they won't do that anymore. But back then when they were first learning chain rule, this is a typical one. So how would you do this one? Let's have a think. When you write, what's the problem here? It's not the square root. It's this one. We don't like the multiple terms. If I replace that with the letter u, this now becomes y equals to the root of u. True? Now, to differentiate this, what's another way of writing square root of u? 1/2. And suddenly, can you see this is differentiable? This is what you were doing now. That was 20b. So 20b, you can differentiate this, providing this was another letter. That's what chain rule is. The chain rule is to be able to look for what can you replace that makes your problem easier is the skill. So here you can see that you've got u is equal to 5x squared minus 2. You'll be able to find delta u delta x. And over here, you will definitely be able to differentiate this because you made it easier, and it's delta y delta u. So the chain rule says once you've got those two, if you multiply these two together, technically, the change in u will cancel out and you'll be left with delta y delta x, which is what you wanted. That's what chain rule is. So if we go back to chain rule, that's what this chain rule is teaching you. So we've got delta y delta u over here. That is 3u squared. Multiply 2. Let's work out what delta u delta x is. So if this is what u is equal to, so I replace this whole x plus 2 with u, what's delta u delta x over here? What's the derivative of this u function? 1. And the derivative of 2? 0. So it's equal to 1. So you put it together. This now gives you 3u squared times 1. Oh, sorry, which is just 3u squared. But you're not done yet. Why is this wrong? Very good. This was saying change in y, change in x. Where's my x? They don't exist. So how do I get my x back? Yeah, because you said u was equal to x plus 2. So your answer should be 3x, whoops. There you go. So instead of expanding this bracket before, that's a more concise answer. And that's the derivative of something like that. This is called chain rule. So in each and every one of these questions here, which we'll practice on Wednesday and Friday as well, every one of them, you can use your current power rule with exercise 17B, 17C, or 20B to do them. Okay, so you got to work on that skill. And you see, there's a lot of parts to this, but as you practice it, you can do them in your head. Differentiate the inside, because that's what you're replacing. Differentiate the inside, and then pretend you're just differentiating the power. That's how I do it. So I look at it and go, derivative of x plus 1, it's 1. Derivative of something cubed, it's 3 something squared. Times and 2 together, that's what I get. So that's how I would do it in my mind. I look at it and say, derive the inside, that's 1. Derive just anything to the power of 3. It's 3 to the power of something squared. Write it in.
So on the exam, it's that means we're not mentally like negative.
Correct. So I will remove marks if I see negative powers. And I will tell the other classes that that's how it should be marked too. I'm pretty sure that's how they mark it, but just to emphasize. Yeah. So textbooks do that at year 11 level. At the year 12 level, they'll switch it all to set answers. All right, so I'm going to stop there. That leaves us to 311. So that's introduction to... No, don't.